Greetings, Joseph Kursky here with you to explore bivariate mapping and scatter plots in ArcGIS Online. Very powerful to be able to do this. One instructional technique that I've successfully used over many years is to have students look at data that is related and also data that is not related. And in this case, I've got mountain peaks and difficulty. The difficulty rating is taking into account things like exposure of trail, the elevation, the length of the trail, etc. So I can make a bivariate map showing 14ers, elevations above 14,000 feet here in Colorado where I am, and I can also make a bivariate map of that. So I'm going to go right now into the scatter plots zone, and I'm going to map difficulty in the y-axis, and the elevation is the x-axis. Traditionally, the dependent variable is the y-axis, so we want to predict how much difficulty is explained by elevation. And in this case, there's no relationship at all. It's almost a flat r-squared curve or line. Why is that? Well, Capitol Peak, for example, is one of the lower 14ers, and you can see the exposure here. That's a difficult peak to climb for sure. And there are some peaks like Mount Elbert, which is the highest in the state, that are actually fairly easy to climb. I've climbed that myself. So why is that? Well, for one thing, the difficulty rating is taking into account 5 factors, so that's a good thing. But the elevation range is not very long, right? It's not very big. So you've got the elevation is not very much dependent on the difficulty and vice versa. Now, what if we mapped, as I have in another lesson, world dominant peaks ranging from the highest point in Australia and the highest point in Hungary and other countries where it's a short walk from the vehicle to get to the top of the peak versus K2 or Aconcagua, etc. Then we'd see more of a relationship. Well, what about here? What if we had county data and we're going to look at the relationship between median household income and the median home value. The home value we're going to put on the y-axis and the median household income on the x-axis. Fascinating. So we can see that about 0.67 is the r-squared. About 67% of the variability in the home value is explained by the household income. So as the household income increases, the home value tends to increase by county in this case. What if we looked at census tract or block group? We might see a different relationship. What if we change the state or the country that we're analyzing? We can also, though, that's the beauty of GIS, not just make a scatter plot, but we can make a bivariate map for both of these variables as well. So now we see the median home value and the median income in 2 different tones, 2 different symbols on the map. We can see, as expected, Pitkin County, Aspen, high home value, high median income. So here we've looked at 2 variables, difficulty and elevation of 14ers in Colorado, not related. We've used a scatter plot and a bivariate map in ArcGIS Online to do that. We also looked at median home value and median income. Turns out they were more related by county in Colorado. Again, leading to additional questions. Why would that be? And is that relationship valid in other parts of the world or other parts of at other geographies and other scales, tract, block group, zip code, etc. So lots of things we're doing here. We're teaching about physical geography, cultural geography, demographics, economics. We're also teaching GIS skills, bivariate mapping, scatter plots, and more. So that's why I love GIS. You can teach content and skills at the same time in a fascinating way, where we ask the what-if questions. What if we change the variable? What if we change the area? What if we change the scale? Thanks for being with me.